Alright everyone, welcome to chapter 3. And it's time to take your modeling workflow to the next level, where we are going to be discussing one of Blender's most powerful features, which are modifiers. So as mentioned in chapter 2, modifiers are a type of non-destructive editing tool because it allows us to retain our original geometry before we apply it. As a small refresher, we can add a modifier to an object by clicking a desired object. And then in the Properties panel, we're going to click the wrench icon, so that's the Modifiers tab, add modifier, and then select one from any of the dropdowns. So if I just preview each of these dropdowns, we can see that there are a lot of available modifiers for us, but I'm only going to be highlighting 4 of them in this beginner's course. And luckily the 4 that I'm going to show you are very easy to work with, super powerful, and also super common. Okay, so in our Create Tutorial Blender file, I'm going to go ahead and just hide everything like this, and this is going to make it easier for us to see the effects of the modifiers first, gauge an understanding, and then we could brainstorm which modifiers can be applied and where to make our modeling process easier for our crate. So first thing I'm going to show you is the mirror modifier, which is an absolute game changer for symmetrical modeling. Let's go ahead and I'm just going to add a cube to my scene, and I'm putting it outside of my crate just to not confuse with the work I've already done with it. Okay, with my cube here, I will go ahead and add a mirror modifier, which is located under generate mirror. You could also use the search bar to access modifiers that you've used very frequently or recently as well. So either way, they're both found under generate mirror. So I will apply a mirror modifier to this cube. So the mirror modifier mirrors a mesh along its local X, Y, and or Z axes across the object's origin. So this explains right now why we visually cannot see any difference because the cube's origin is in the center. So if you mirror an object across the local X axis, it's just mapping that duplicate on top of itself. So I can show you that this is taking effect if we go to the statistics. So under view overlays, let's enable statistics, and let's us disable this computer icon to take away the visual effect of the mirror modifier. So as expected, the statistics of my cube are what I know to be 8 vertices, 12 edges, 6 faces. And if I apply the real-time display of the mirror modifier, we can see that all of those numbers have doubled. Okay, so the mirror modifier is still taking place, but it's just being mirrored on top of the original one. So with the x-axis enabled, well, let's try to move the object somewhere along the x-axis. So let's say if I drag it here. Well, nothing happened, which is what I also expect, because remember, the cube's origin is still in the center. So the mirrored mesh is still being mapped on top the original one. So I need to change where my origin is. So if I right click on this cube to change the origin, and let's say if I set it to somewhere else, let's go to 3D cursor, which is at world origin here. So if I set it to 3D cursor, now I could see the mirrored mesh being placed into the scene, which is equidistant on both sides of the world origin along the x-axis. Okay? Now, of course, if I switch to the y and z axis, it's not going to do anything because this cube is still placed on y and z equals 0. So again, if I mirror it along the y or z axis, it's not going to change for the same reasons why it didn't change for the x-axis as well. Okay, so with the object's origin and world origin, if I tab into edit mode, I can see that any change that I make to my original mesh, it's also going to be mirrored in real time. You also cannot directly modify the mirrored mesh until you've applied the modifier. So this allows you to focus only on one mesh at a time. Now what's super cool about this is, as you may have guessed, you can build symmetrical objects simply by only working on one side. So if I place the origin back into the center of the cube like this, let's put it back into world origin by zeroing out the location. And what I want to do is I'm going to put this on one side of the x-axis. So that means I want to move this side of the face along the YZ plane. So what that would look like is I want to move it somewhere here. So everything is on one side of the x-axis right at the middle. And this shift is just 1 meter. And I got that 1 meter because the dimensions of my cube are 2 meter on each side. So I'm just moving it this half distance away, which half of 2 is just 1 meter. Now, if I set the object's origin back to the 3D cursor, I can see that the mirror object appears where I want it to be, but most importantly, these two objects are stuck together thanks to this merge option that is enabled over here. So, and I can showcase this a little bit better in wireframe mode. So you can see that the objects are next to each other. So when merge is selected, neighboring vertices within this specified merge threshold are going to merge together into one vertex, preventing duplicate ones. Okay, so visually, these vertices, there were originally two here. One from the original cube and one from this mirrored one. And because I set merge, they've combined together into one. So we can also verify this by, well, just doing some basic math. Let's disable the merge option right now. So one cube has 8 vertices. So therefore 2 cubes are going to have 16 vertices, which is what my outliner shows here. But now because these 4 sections of vertices in the middle, these initially have 8 vertices in total, but each of them have been paired up into a single one. So now I only have one single vertex in each of these spots. So those 8 vertices changed into 4. So I've lost 4 vertices thanks to merging. So you can see that if I enable this merge option, it goes down to 12. Okay. Now, of course, this option only applies for vertices. I still have this middle face that's part of the cube. And I can see that in edit mode because I can still select this part of the cube. However, this face is inside my created mesh that I have here. And because it's never going to be seen, it's a great idea for me to just delete this face just to save geometry. Okay? And you can see that I still get the same exterior result. But now with my geometry a little bit more reduced and optimized. The merge option works very well in tangent with the clipping section because clipping prevents vertices from moving through that mirrored plane when you transform them into edit mode. So what this looks like is, well, with this clipping turned off, if I go into edit mode, you could see that if I take any of these vertices, so let's use the vertices that are merged in the middle that are along the mirror plane. I can move these vertices wherever I want, and I get this sort of motion here. And I could also take any other vertices that are not on the mirrored plane, and I also have freehand movement of them as well. Now if I enable clipping, a couple things happen here. It prevents any vertices on one side of the mirror plane, and it tells it to stay on that side of the mirrored plane. So these vertices that are connected in the middle, that lie along that mirrored plane, you can see that they are stuck to each other. So I actually can't move this vertex anywhere on the left and right side of the x-axis. They're merged together and clipped together. Now if I choose any one of these other vertices that are farther away, you could see that I can move them freehandly, but the second I try to move them across the mirror plane, Blender stops me in my tracks and tells you, you can't do this. So this, using clipping, allows you to control your vertices a little bit more, leading to cleaner symmetrical results. And of course, if you're doing something without using clipping, let's say that you're trying to change the location of the middle one, just know if you're not careful enough that you can lead to inexact measurements very fast. Lastly, if we don't want to play around with the object's origins, we could also use this mirror object tool, which gives you access to this eyedropper and this dropdown as well of all of my objects in my scene. And depending on the object that I choose, it's going to use that object's position and rotation to define my mirror planes. Okay, so if I fix this cube, let's just move this out of the way. Actually, it's just easier for me to delete it. So let's just add a new cube and add back the mirror modifier, like this. So let's move it somewhere over here. And now I want to create a mirror object. So I'm just going to go ahead and create another cube, and I will change the look of it a little bit just to differentiate between my cube and my mirror object. Okay, so using this mirror object, I'm going to use the eyedropper, and I want to say this cube, which is cube.001, I want this to be my mirror object. So I'm going to select it, and I get the mirror object over here. So this works the same way how if this object's origin was in world origin. But you could see by doing it this way, I maintain the origin of this cube. So it doesn't have to be somewhere far away in Abyss, just for the purpose of mirroring. Okay, we could also see that the rotation of this object also plays a role in it, because if I rotate this object, the mirrored one will be moved. But honestly, this can be very confusing to start off with. And if ever a situation comes up where this might be useful, you can have the ultimate decision to use it or stick with another easier approach. Okay? And who knows, maybe down the line we will find a use case for the rotation of an object, and we could talk a little bit more about it then. Okay, and although there are other settings in the mirror modifier, such as bisect, flip, and even all this data stuff, these will be the ones I'm most comfortable sharing with you to start off with. Okay? And just know that there are Blender manuals online that will go through each of these fields again and tell you exactly what it does, just in case you forgot or need a refresher. But I've personally found everything that I've shown you so far to work just well for me in practice. Alright, so next is the array modifier, which allows you to duplicate objects the smart way. So I've just deleted all of the cubes that I used for the mirror demonstration, and I'm going to start with a new one. So the array modifier is found under generate arrays, first one alphabetically. And what the array modifier does in general is that it creates arrays of copies of the base object, think of it like duplicates, with each copy being a specified offset from the previous one. So the fit type here controls how the length of the array is determined. So starting off, fit count generates the specified number of copies. So here my count is set to 2, so there are 2 cubes in my array. If I bump up this number, you can see that, well, now I have 5 cubes in my array, and so on. So currently I have a relative offset here of 1. And relative offset is a scaling factor that is being multiplied by an object's bounding box size. And a bounding box is just the smallest box that you can create around your object such that it's fully contained inside of it. So in the case of a cube, the bounding box size, well, the cube is already a box, so the bounding box is just the cube itself. So if I increase the scaling factor here, let's say to 2, this new cube gets placed over here, and we get a gap. And the size of this gap is actually the same size as the cube itself. Okay, if I move the scaling factor up to 3, well, then we get a bigger gap, and the size of this gap is the same size as 2 cubes. So you can think of a scaling factor as how many of your meshes away should the next one be generated. So this one is 3, so this is my starting one, so the next one should be 1, 2, 3 spaces away. Okay, and of course a decimal factor gives the same application. So this one is saying that I want the next one to be, well, if it was 1 cube away, that would have initially been here, but then that 0.5 says, okay, put another half space away. So this space created is the same size as half of a cube's gap. And of course, the same principle is applied to if you use this factor to any of the other axes. Okay, instead of relative offset, you can also use a constant offset. So this one might be a little bit easier to show in wireframe mode. And what constant offset allows you to do is precisely specify the distance between adjacent objects. So in my current setup, I have an overlapping array of meshes where my distance is actually set to 1 meter in the x-axis. So this is because my starting cube, which is right here, the origin was at x is equal to 0, and I told it to generate my second mesh with a constant offset of 1 meter in the positive x direction. Positive x because my number 1 here is positive. So that means my next cube's origin will be right here, which is x is equal to 1, which is 1 meter away. And this generated mesh creates overlap because my original mesh is actually 2 meters on each of the dimensions. So if I don't want any overlap, and let's say if I wanted, let's disable the real-time display. Let's say if I wanted my next one to spawn right next to it, which is right over here, well, therefore the origin will be right here with an x coordinate of 2. And therefore, if I want to use the constant offset, with this being x is equal to 0, I need this to be 2 away. So if I change my distance to 2, and if I put the real time back on, the next duplicated mesh from the array gets placed exactly where I wanted. Okay, and of course, just like the previous example, you can use this in tangent with multiple axes at the same time. So if I also specify, let's say, z to 2 meters, the next one is going to be placed 2 meters away in the x direction and in the z direction as well. The object offset, this is a little bit more advanced, and it's also not needed for this beginner course. I found that relative and constant offset is far more appropriate for everything that we need to do. Okay, and similarly for the mirror modifier, this merge checkbox over here will work the same way. So it's going to merge vertices that are next to each other within the specified distance threshold. So in this case, I have with merge enabled. What happened here is that, well, these vertices from both of the cubes are next to each other, so they have been merged into one single one. Okay, and these same sort of options work if I change the fit type to fit length. So what this one does is that instead of generating a number of copies, it's going to generate the appropriate number of meshes to fit within the specified length, taking the object's bounding box distance and offset distance into consideration. So in my example, my cube is 2 meters long in the x-axis. So if I set a scaling factor of 2, so relative offset factor of 2, I know that my next cube is going to be located here. And the object's origin will have an x coordinate of x is equal to 4. So, with my scaling factor 2, if I set my length to be equal to 4, that new mesh gets placed exactly where I want it to be. Now, if this value was a little bit less, let's say 3.9, nothing's going to generate because I no longer have a length long enough to generate that next mesh. Okay, so I need 4 here. Now if I wanted to generate another one, well, with a scaling factor of 2, that means the next one will be over here. That means the x coordinate of this cube will be x is equal to 8. And you can see here that if I slowly increase the length, nothing will be generated until I reach that length is equal to 8 meter mark. Okay, so you could see here that in this example I have here that it looks like another mesh is not going to be spawned or generated unless my length is another multiple of 4. So math always comes back to help us whenever we want to be precise. Great stuff, and This is all that we really need to know for the array modifier. So next is the bevel modifier. So let's just delete all of this again, add back a new cube, and let's add in a bevel modifier. So this is generate and bevel. So we've seen a little bit of this action in chapter 2, and essentially it bevels the edges of a mesh in a non-destructive way, as opposed to the bevel tool in edit mode, which beveled our mesh in a destructive way. So at the top here on the bevel modifier, we can see two options here. We can see one for vertices, which is going to bevel the areas right around the vertices, leaving most of the edge unchanged. And the edges option is going to bevel the edges, creating intersections here at the vertices, which this option here for the edges is a little bit closer to what the bevel tool in edit mode did. The width type defines how width is interpreted in our bevel. So to start here, offset is the distance from the new edge to the original. So you can imagine here that with my original dimensions of 2 on each side, so if I take off the real-time display, this vertex was right over here. And if I display the bevel here, this new vertex got shifted away by the amount specified, so 0.1 here. So this is 0.1 meters in distance. Now, of course, if I change the amount to, let's say, 1 meter, then I would expect to get this shape, because the vertex that was over here, which I can show you again, this one was at x is equal to 1, and hence with an offset of 1 meter, it gets sent all the way here. So 1 meter down the line, this one gets set at x equals to 0. And the same process happened for this vertex, which is at x is minus 1, and then it got offsetted to 0 as well. So this gives us this like 3D diamond shape. The width option is the distance between the two new edges formed from the bevel. So it will be this distance right here. Okay, and the depth option is the perpendicular distance from the new bevel face to the original edge. Okay, this might be a little bit easier to if I decrease the amount of the depth amount. So what happens here is, let's take away the real-time display. So my original edge or vertex was here. Let's add the bevel modifier. And what this does is the perpendicular distance between this triangular face over here and this edge. So it is this distance right here. So this is the depth. Okay, the rest of these options here are realistically, I just never use them. So I'm not going to cover them. And every time that I use the bevel modifier, you will most likely see me using the offset option a lot because it's the easiest to work with for me mathematically. But honestly, anytime that I'm using the bevel modifier, this is one of the modifiers where I just look at it visually and change the offset until I like the feel of it. Okay, let's put back that display. Now the segments. So the segments specifies the number of edge loops that are created. So you can see that as I increase the number, more edge loops are created, giving a smoother beveled look. But obviously in turn we have much more geometry. Now lastly is the limiting method, which controls how a beveled is applied, or where a beveled is applied. So none means that there is no limit. That means all my edges get beveled, and the rest of these options have some math to do with it. And this could get honestly very confusing very fast for a beginner. So let's just stick with the default settings. So we're going to set the limit method to angle and just keep the angle at 30 degrees. And we're just going to call it here with the bevel modifier. Lastly is the Solidify modifier. So let's add back another cube. And I'm going to add a Solidify modifier to this one. So what the Solidify modifier does is that it takes the surface of any mesh and it adds depth or thickness to it. So it's very hard to see for a 3D example. So to make it simple, the Solidify modifier is generally used for 2D meshes. So let's add in a 2D mesh. So that is a plane. So this is a two-dimensional mesh. Add back that Solidify modifier. So we can create a shape with our plane and then use the Solidify modifier to add some thickness to it. And this is specified by the value I set for the thickness or the depth of the object. Okay, and the offset here is a value between -1 and 1, which specifies the ratio between how my thickness is going to be distributed in my shape. So if I set my thickness to 0.5, now my plane is now 0.5 meters thick, which I could show you in my transforms panel. You can see that Z dimension is 0.5. And if I set an offset to be right in the middle, which is 0, you could see that that thickness got equally applied above and below the object's origin. If I set this offset to 1, all of that thickness got applied above the plane. And if I set that offset to -1, all of the thickness got applied below the plane. And just like the mode, that's all we're going to look at to keep things simple. Great. So I didn't want to start jumping straight into applying these modifiers directly on our crate because I realized in hindsight that this video is going to turn out to be super long. So I've broken the application part of these modifiers into a 0.5 lesson, which is coming up right after this one, thus allowing me to separate theory from application. So we've gone through 4 helpful modifiers, and now it's time to start putting them into practice. So if you'd like, before the next video, see if you want to play around with these modifiers to get a better feel for it. And if you want, see if you can brainstorm where any of these modifiers can be used appropriately in our crate to therefore ease our workflow. So give it some thought, I'll give you a second, and when you're ready, join me in the next video, and we're going to start applying these modifiers to our crate.